We're looking at the quiz Trig quiz 2 review. Okay, so number 1, y is equal to 4x cubed, tangent of 4x cubed. If we want to find the derivative, find dy dx. Looks like we'll have to go through a combination of product rule and chain rule within this tangent here. So let's go through product rule first. F prime g plus fg prime. So we need to take care of the derivative for 4x cubed, so that becomes 12x squared going through power rule. The g function is the original tangent, so we bring that down, plus 4x cubed is the f function, so we bring that down for the second portion, and then g prime, the derivative for tangent of u is secant squared of u times u prime, and the derivative for the u value, the 4x cubed, becomes 12x squared, and that's as far as we can go. So that's our y prime. Number 2, cosecant of 4x over cotangent of 3x. We can go through quotient rule. We have these two functions related to one another by division. So to find the derivative, we have to go through quotient rule. So f prime g minus fg prime all over g squared. We'll let the f be the numerator and then the g be the denominator. So f prime, the derivative for cosecant of u, is negative cosecant of u, cotangent of u times u prime. U primes is the derivative of 4x, which is times 4, times g, so that's cotangent of 3x, minus f, so the original f function is cosecant of 4x, and then g prime, the derivative for cotangent of u, is negative cosecant squared of u times u prime, so the derivative for 3x becomes 3, all over denominator squared, all over g squared. And we can clean this up a little bit. We can pull the negative 4 out in front. And for the second expression here, we can pull the 3 in front. The two negatives cancel out to be positive, but there's probably not too much more that we can do with the to simplify the derivative. Okay, number 3, cotangent of y equals 3x sine of 5x. Notice that the y is mixed within the equation, so we have to go through implicit differentiation. Product rule, because 3x and sine of 5x are two separate terms that are being related to one another by multiplication, so we have to go through product rule. Alright, so let's take care of the left side first. Cotangent of y becomes negative cosecant squared of y times y prime, and then we denote y prime as dy dx, okay, because we're involving y's derivative. Alright, product rule, f prime g plus fg prime, so 3x becomes 3. The original g function comes down. F function is 3x. And then g prime, the derivative for sine of u is cosine of u times u prime. The u value is 5x, so the derivative, or u prime, is simply 5. All right. Now we have our derivative found. We just have to isolate the dy dx. So we can move the negative cosecant squared y by dividing it over. And we can simplify the numerator a little bit. 3 sine of 5x, 3x, and the 5 can combine to be 15x. Number 4, we have 4/3 tangent of 4 theta. 4/3 is just a coefficient, so really just take care of the tangent of 4 theta. So the derivative for tangent of u is secant squared of u times u prime. Our u value is 4 theta, so the derivative for 4 theta is simply 4. So we have our derivative. We can just clean this up a little bit, bring this 4 out in front to share with the coefficient, so 16 over 3, secant squared of 4 theta. Number 5, find the equation of tangent line to the curve. So in order to find the tangent line equation, we need to find the order pair, we need to find the slope, and then put into point slope. So to find the order pair, to find the point, we can plug the 2 pi over 3 into the original equation. So cosecant of 2 pi over 3, we can think of cosecant 2 pi over 3 as 1 over sine of 2 pi over 3. And we know sine of 2 pi over 3 is root 3 over 2, but if we flip that, then we have the cosecant version of it. So 2 over root 3. And then if we rationalize it, it becomes 2 root 3 over 3. So that's our order pair, 2 pi over 3 and 2 root 3 over 3. To find the slope, we need to get to the derivative first. So the derivative for cosecant of x is negative cosecant of x, cotangent of x. To find the slope from there, we can evaluate the derivative at the x value. So plug 2 pi over 3 in for the x's. So negative cosecant of 2 pi over 3, cotangent of 2 pi over 3. Cosecant of 2 pi over 3 is 2 root 3 over 3, and then cotangent of 2 pi over 3 is negative root 3 over 3, and two negatives cancel out to be just 2 over 3. So that's our slope. We have our slope. We have our ordered pair. And now we can plug in the point slope. Y minus y sub 1 is equal to the slope m, which is 2/3, times x minus x sub 1. All right, number 6, we have the position particle that's given to us, x sub t. Find the acceleration. So to get to the acceleration, we have to work our way down to the second derivative. And then once we get down to the second derivative, we can plug 3 power 4 into the second derivative. But first things first, we need to get to the velocity function, the first derivative. So the derivative for cotangent of 2t becomes negative cosecant squared of 2t times 2. In other words, negative cosecant squared of u times u prime. Clean this up a little bit. We get negative 2 cosecant squared of 2t. So this is my velocity function. Before we get to the before we work our way down to the acceleration, I'm going to rewrite this because that squared is really over the entire cosecant expression outside of the negative 2. So I'm going to pull the 2 out. Makes it a little bit easier to visualize the chain rule that needs to happen. All right, so now we should be ready and set for us to go through chain rule to find the second derivative, which is acceleration. So we're going to take care of the exponent outside the bracket first. So the derivative, bring down the 2, keep the bracket, subtract 1 from the exponent. Now we multiply it by the inside function, or the next function in, which is cosecant of u. Cosecant u's derivative is negative cosecant of u, cotangent u times u prime. The derivative for 2t is 2. So we have our acceleration function. We can clean this up a little bit, pull all the coefficients and the negative out in front, the 2 negatives to become positive. So 8 cosecant squared of 2t, cotangent of 2t. Now we can replace all the t's with 3 power 4. So 8 cosecant squared of 6 power 4, or 3 power 2, cotangent of 3 power 2. And then that reduces to be just 0. So 8 times 0 times 0 is simply 0.